In this video, I want to show you an example of the math behind Avogadro's law. Now, I'm not actually going to test you on this information. I just want you to see how the relationship works mathematically. So let's do that with an example. The initial volume of a balloon is 1.7 liters, and it contains 2.1 moles of gas. If some of the gas is let out and the volume of the balloon decreases to 0.5 liters, how much gas is left inside? So this question gives us a bunch of information. We know that the initial volume, or volume 1, is 1.7 liters, and that volume 2, or the final volume, is 0.5 liters. We also know the initial number of moles, or the amount of gas, is 2.1 moles. What we don't know, or what the question's asking for, is the final number of moles. So we'll call that our variable x. Now let's talk about the equation for this. We know that when the volume decreases, the amount, or the moles, also decreases. So we know that this is a direct relationship. So we kind of have two options for this equation. So one of these equations shows a direct relationship, and one of them shows an indirect relationship. And we want to think, are the moles at the end going to be more or less than at the beginning? Well, we've decreased the volume, so we need to also decrease the amount. And we know that if we release some of the gas from the balloon, there's going to be less gas left in the balloon. So one of the equations here is going to give us a lower number of moles, and the other one is going to give us a higher number of moles and be wrong. So which equation do we think it is? Let's look at a really simple example of each equation. So I've changed the numbers to be really simple to try to show you this relationship. I see on this side, if I plug the numbers in, I've got a 6. And on this side, in order for this to be equal to 6, I'd have to multiply by 6 moles. That would be increasing the amount, because it's way more than my 2.1 moles. So this is an indirect relationship. If I do the same thing with these numbers in my other equation, I find my second amount of moles is 1.5, which is less than I started with. So this is my direct relationship equation. So now let's actually solve this problem. So I know my N2 or my second amount of moles, or I can write that as my variable x. And it goes down to 0.5 liters. Now to solve this algebraically, I'm going to have to multiply both sides by the 0.5 liters. Which gives me 0.62 moles. Therefore, there would be 0.62 moles of gas left in the balloon. So what I want you to see here is that we can use the relationship between two variables to solve problems. But what I want you to focus on is the actual relationship that when volume decreases, the amount of gas decreases. And the important thing is that you can explain why that is, and not that you can solve some sort of mathematical calculation about it.